This is 2021 paper 1 question 7. We're told that each successive length is 90% of the previous. So let's take 45, multiply it by 90%, and you will get 81 over 2. Multiply this by 90% and you'll get this. That's how you know you're doing it right. Then multiply that by 90%, you got 6561 over 200. And then multiply that by 90%, you get 59,049 divided by 2000. So yeah, it's just filling in numbers. Then we're told the general formula, and we're told to find the arc length of string 25. So we just have to plug in n equals 25. So the 25th arc length will be equal to 45 times 0.9 to the power of 25 minus 1. That'll give us 24. Put that into your calculator, you'll get 33.5894 roughly. And that's just a one decimal place, so that's about 3.6. And the unit given in the question is centimeters. Then we have to find the total distance traveled by basically the total distance traveled. So it's going to be adding up all those arc lengths because that's for each swing. As for swing number 40. So we need to add them all up. So we're using the sum of a geometric series because we're multiplying by 0.9 each time. So it's geometric. So we have 40 swings. So n equals 40. Our first term is 45. That's the starting length. And we're multiplying by 0.9 each time. So we can say that S of 40 will be equal to 45 times 1 minus 0.9 to the power of 40, all divided by 1 minus 0.9. Put that into your calculator, and what you should end up getting is 443. So that's exactly equal to 443.3486, and that keeps going. It says the nearest whole number, so that's roughly equal to 443, and again, the unit is centimeters. Then we're told that swing P is the first swing where the arc length is less than 2. What's the value of P? So we're not looking at adding them all up anymore. We're just looking at this formula. So basically, we'll have 45 times 0.9 to the power of n minus 1. We want to see when is that equal to 2. It says less than 2, but we can find it equal to 2 and then do a little bit of reasoning. So divide both sides by 45. We'll get 0.9 to the n minus 1 will be equal to 2 over 45. Fastest thing to do here then, you can take log of any base, but fastest thing to do is log base 0.9 because that'll cancel out the base of 0.9, the exponential. Then what we get is n minus 1 will be equal to, so I'm just going to bring the 1 to the other side, and we'll get 1 plus log base 9 of 2 over 45. So all I did there is this will be n minus 1 equals this, and I just brought the 1 to the other side. So you can just put that into the calculator, and what you'll end up getting is that n will be equal to 30.55 roughly. Now we have to think about what this means. So it'll be exactly 2 after 30.55 swings. So that means if it's 30 swings, it's going to be bigger than 2 because the arc length is decreasing. So the first time that it's less than 2 centimeters will be n is equal to 31. So that means that our P will be 31, which is what they asked us for. Then we're told that the length of the pendulum is 1 meter, and we have to find the angle. So the way you need to think about this is that the pendulum is like this, and like here's the bob at the end, and it's going to be swinging back and forth in kind of the shape of a circle. So the first arc length that we have is 45. The length is 45 centimeters. So what's the circumference of an entire circle? Well, it's going to be 2 pi times the radius. I'm just going to keep everything in centimeters. So in this case, the full circle will have an arc length of, it'll be 2 pi times 100 centimeters. But the thing is, we don't have the full circle. We only have theta degrees out of the 360 total degrees. So we don't know how many degrees we have, but we have some proportion of the 360. And that ratio, when you get that amount of the circumference, you should get 45 centimeters. Okay, so this is the entire circle. We're only taking a fraction of it though. We're only taking theta out of 360 degrees. And when we do that, we should get 45 centimeters. So then we can solve for theta. So what we can get is, well, we need to get theta by itself. So multiply both sides by 360. We'll get 2 pi. Well, I'm going to say 200 pi when you multiply the 100. So we'll have 200 pi times theta will be equal to 360 multiplied by 45. Then divide both sides by 200 pi, and theta will be equal to 360 multiplied by 45. That's multiplied by not a decimal. Divided by 200 pi. And you can just put that into the calculator, and you'll end up getting about 25.78 degrees. And then I'm assuming it says, yeah, to the nearest degree it's 26. So this is roughly equal to 26 degrees. And that's what the question asked us for. Then we're told to find the total accumulated angle that it swings through. So the sum of all the angles. So if you think about it, the first angle is 26 degrees. And then if it's traveling 90% less arc length, it's reasonable to assume that it'll travel at 90% less angle. So we'll have 0.9 multiplying by that, so it's going to get 90% smaller. And then we multiply this by 0.9 to get the next one. So we'll get 0.9 squared times 26 degrees. And then we keep doing that. And it says until it stops swinging. So we're just going to go off to infinity. So going off to infinity, we use this formula. So we have the sum up to infinity. And it's good to understand where this comes from. I think they actually can ask it. So our first term is 26 degrees. And then we're dividing that by 1 minus 0.9. Because that's the common ratio. 0.9 is what we're multiplying by each time. So the total angle will be 260 degrees. Because we're just dividing by 0.1. So that's the same as multiplying by 10. Then we're told to find the total distance traveled by the tip when it's moved half through the total accumulated angle. A few different ways of doing this. The way that I think is easiest is this is like 260 degrees of a circle that are being traced out. So half of that is 130 degrees. And then the circle in question, well, we're getting 130 degrees out of the 360 degrees. And then the circumference, so it's 2 pi times 100 centimeters, because we're told that's the length of the pendulum. So basically, this is the entire circle. We only want 130 of the degrees. So we basically do that. And what we end up getting is 226.89 centimeters, roughly. And that's just the nearest integer. So we'll say 227 centimeters. The other way you could have done it is you could have said half the distance. So the total distance, when you use the sum of infinity formula, the total distance is going to be 450, and you could just half that as well. So your A would be 45 because it starts with 45 centimeters. Then divide that by 0.9. And then you get 450 and put that in half, and it's 225. So you get a similar answer. Obviously, there's just a bit of difference because of the rounding here. This angle is not exact when we say 26 degrees.